Cool, thank you. Hello, can everyone hear me? Yes. Perfect. Hi, yeah, I'm Tobias. Thanks, Brian, for the introduction. I'm one of the co-founders of growthepie.xyz. I'm going to go into details later on about the platform. My title of this talk is Economics of Ethereum Layer 2s and their Data Availability Solutions, because there's a huge discussion around, okay, are all these layer 2s, layer 3s actually viable? Why do we need them? And then all of these data availability blockchains that we have now as well. So do they not take away fees and actually revenue from Ethereum itself, right? So is Ethereum itself actually then sustainable in the long run? And this talk is not going to be very technical, I think. It's going to be more from the, let's say, the design side and the economic side. So I hope that's all right with all of you. And I'm going to give a little intro about myself, about growthepie and the data, and have some examples. And actually one example that I'm going to go through, and later on we're actually having a look at live data as well. So quick background, I'm the design co-founder basically of growthepie, because for us it's very important that we actually have a good accessibility to the data that we provide. And exactly, the rest is actually not that important. And growthepie.xyz, if you don't know it, is a data analytics platform that we established in February 2023. And it's Ethereum Foundation funded. We got a couple of Optimism grants after that, and kind of really have this platform as a public good. So everything's free to use, of course, the platform itself, but also the data you can get through our API and have your own, make your own analysis and whatever you want to do with it, actually. Going to have a little example about that later on as well. And what you can actually see on growthepie is we started as purely layer 2 focused, but now since the whole narrative is also changing, right, because layer 2s and layer 3s are also Ethereum, right? That's the whole purpose of this whole roadmap of Ethereum. And so we're going to have much more Ethereum data in the near future as well. And then right now we're tracking at least 24 layer 2s. So what you can do on growthepie is that you can have fundamental metrics like activity metrics, but then we also have economics metrics, and we do a lot of smart contract labeling. So that allows us to actually categorize the usage of different layer 2s, and people can actually see, okay, why would I be on a different layer 2 at any one time, and what's running on these different layer 2s. And we have more data availability metrics, etc. And why actually this talk? So I kind of already touched upon this. Like we have now, if you also go to L2Beat, if you're familiar with that, like we have more than 100 active scaling solution projects, right? I mean, we have bigger ones, of course. I got a screenshot from our landing page. Of course, the biggest one, obviously, right now by far is Base, then followed by Arbitrum 1 and OP Mainnet. So these are the bigger stacks, right? But then, of course, we have like some others coming up that are also like building more and more and kind of differentiating also through the tech, but also the accessibility through the usage. And of course, like now, when we look at that, everyone said we are now at DEF CON in Bangkok, right, 2 years later after Bogota. And these were like my main takeaways 2 years ago. So Ethereum needs to scale. Okay, we're getting there. Ethereum needs to be cheap. Also got there. We're going to look at that later on. And Ethereum needs better UX. But now if you actually think about that, so if we go one back, all of these different layer 2s, okay, like where's our better UX, right? That's a different topic to solve, but we're talking more about the economics and why actually does it actually make sense to have these different layer 2s. So going into different like industry or drawing a comparison would probably be like 3 different main industries that we all benefit from. Right? So we benefit from cloud computing, from telecommunications and transportation when you think about it. So cloud computing, like probably most of us that are, like software engineers, builders, and so on, we are using probably AWS or Google Cloud or any other service like this. And of course, they charge for computation, they charge for storage, and Ethereum charges for transactions, right? And until a couple of months ago, that was actually pretty expensive. Telecommunications providers, like what the metrics are that we typically look at there is like the bandwidth, right, and the latency. So we want to, if we want to send a message anywhere in the world, we actually want it to go through straight away. We want a high bandwidth, especially think about when a lot of people are in one place. We usually have that problem with a couple of telecommunications providers that there's actually nothing going through anymore, right? So this is also a metric that we can look at around blockchains as well. And then, of course, obviously, also transportation. Right? Transportation, when you think about it, especially also like here or in Latin America, we have like a lot of cars, a lot of vehicles, right, in one highway. And of course, we're building more and more highways to actually kind of tackle the congestion that we actually have. And that's the same thing that we do with different scaling solutions, right? So we have a couple of optimistic scaling solutions, so basically where everything's pretty fast, because an optimistic scaling solution would say, look, we are actually trusting the transaction, that it's actually valid, and only if fraud is suspected, that would then be reversed for like 7 days. There's a couple of, so you have some time there. And then CK rollups, they actually take this whole computation about fraud detection off-chain, so they have a lot of high computation off-chain. That's going to be relevant later on when we look at actually some metrics. And then we have a couple of other, obviously, like scaling solution technologies like state channels, plasmas, and so on. So they are all for different purposes, right? And so what are we going to look at actually, and how does data actually help us to decide, especially as a builder, to actually see, look, what should I be using, on which, let's say, layer 2, layer 3, should I maybe have my decentralized app on, or even if I'm building my own L2, L3, right? So what would I actually, like how can I analyze data to actually say, okay, that is the right solution for me, because we have different stacks, right? We have Arbitrum Orbit, which is then optimistic based. We have the CK Sync Elastic Chain, which is obviously zero knowledge based. And so you can actually see through data, okay, how do you actually decide on the right tech for you? And we are going to look at this in a practical example as well, but just that you already know, like the transaction throughput, so which is a crucial metric, right, for actually analyzing, okay, how much capacity does this scaling solution actually have at any one time, right? Imagine there's a lot of people coming now and want to do one thing at the same time, and this the scaling solution doesn't actually have the capacity. I mean, there's a lot of criticism around that at the moment, where other blockchains, especially layer ones, are actually more efficient, right, because they have more throughput. And then we also look at the fees paid by the users, or the revenue for the chains, because a chain needs to be viable, right? We had this example with the public goods network, for example, by Gitcoin. This was not a viable solution because they wanted actually to share a lot of the fees that were generated by transactions with, let's say, public goods projects that are launching on the chain or somewhere else, right? And this whole solution wasn't viable because the costs were just too high. And then we, of course, we have the settlement and DA costs. So normal ones would be, let's say, we have different solutions that say, okay, I'm actually using Ethereum for my data availability as well, so for my data storage, using call data, using blobs. And then we have other alternatives that is, for example, Celestia as a like focused data availability provider. And then we have, of course, like security centralization costs. That is, for example, when we talk about based rollups, so it has nothing to do with base, but let's say that use a decentralized sequencer that is actually using Ethereum mainnet as a sequencer, right, which is a bit more expensive, but we're going to have a look at that as well. And I talked about it, like I have a few examples what we can actually look at. So I talked about the throughput, right? And for example, when you now, let's start with Ethereum itself. So we have Ethereum enabled, and you see this flat line here. the gray line, which is Ethereum. And there you see Ethereum is always at capacity, right? So that's why the fees are so high on Ethereum mainnet, right? Because after that, of course, you have to pay a premium to actually transact on that, to actually like that your transaction goes through. But we already saw that with a couple of other layer 2s as well. So I have like 5 enabled here or 6 enabled. And then you see here this blue line. I mean, that is base. And you see these steps like a staircase going up. Because base has the goal to actually go to 1 giga gas per second, so to have a lot of throughput, right? So to enable cheap transactions for a long time for their users. And that's why they're upping their throughput all the time, so upgrading the tech, but they have to be careful with that as well, so that actually like they have enough uptime, right? But as you see right now, they're also again at capacity, so they upgraded that in October, and again, like there's enough transactions to actually fill the whole capacity of the whole chain, right? And then you see some others like Arbitrum here, that's actually never at capacity right now, and Optimism, OP Mainnet also upgraded their throughput right now, which then again shows you, look, if you're a builder, for example, okay, like does this chain where I'm building on actually have enough capacity for my type of app? For example, if you're building a game, right, we all know, like if you play a game, you have a lot of maybe tiny microtransactions, so let's say OP Mainnet might not be the most suitable for that, for example. And then, of course, we always talk about viability as well. And after EIP 4844, where Ethereum introduced blobs to kind of be more efficient with data storage, we had this whole fall in fees, right? I mean, for us as users, very good, right? Because of course, we don't want to pay, I don't know, $1, $2, or like, I don't know, hundreds of dollars on Ethereum mainnet. We want to have these low fees, so that happened in March, right? So after that, you saw like all these chains slowly upgraded to using blobs. Not all of them. So for example, Polygon CKEVM. So I'm not talking about Polygon the sidechain, because that's what we not consider a layer 2, because it's not actually settling on Ethereum mainnet, right? But Polygon CKEVM actually still uses only call data. They haven't upgraded to blobs, but are still managing to actually be quite cheap. And basically, so what does that mean? Do you then have not enough profit, right? Or like, do you not generate any revenue anymore, right? When you have all these cheap fees. But actually, when we look at it, base right now, so in just yesterday, that screenshot, or like last 30 days actually, that screenshot was taken today, they made $4.31 million in profit, right, in the last 30 days. Just profit. It's not revenue, it's profit. On-chain profit, I must say. And so it's still clear they are very viable. Also here you see at the peak, probably here in March, where they had a lot of transactions. So after blobs were introduced, they now started moving more and more users to the actual chain. And now you see they had, in that month, more than $15 million in profit, right? And well, then there's June 20th, right? And so then we have a couple of winners and losers, because here when we look at the revenue, that is actually quite interesting, because the revenue was pretty high for Arbitrum 1. Because there was I think it was a layer 0 airdrop or some other huge airdrop, and they had to kind of claim that through Arbitrum 1 actually. So Arbitrum 1 on this day made 500,000 in revenue, right, from transaction fees. So you see, even with low fees, it's actually possible to still generate a lot of revenue, because I think when we talk about and that's why we are actually, I mean, a side note called kind of grow the pie, because I mean it might be a bit naive right now, but we say, look, if we actually have enough users, it's possible to not have a zero-sum game, right, but have a positive-sum game, where like there's an actual need for all these different layer 2s, because you're going to split up your target groups anyways, right? So like, remember that? So Arbitrum 1 has a lot of revenue on this day, and base and linear, so focus only on these 3. And But when we look at this now, so we're talking about the on-chain profit. So that is excluding the rent that you have to pay then to L1 and other costs, like just on-chain cost. So on this day, Arbitrum actually made a lot of profit, right? Like 3 million in profit. And then we see Blast, we see OP Mainnet, and we see Base, and Base actually lost money on this day. So that's a huge question, right? Because why do they lose money? And when you actually see that, it's also the same day, and the cost of Ethereum blobs. So we have a logarithmic scale here. They were actually like pretty low, like on blobs, because like blobs are almost costing nothing most of the time until now. But then on this day, because of the high transactions and on Arbitrum 1, so Arbitrum basically kind of was really efficient with all these blobs, and but also the builders actually didn't kind of use these blobs or take away the blobs, right, to kind of make place for new ones, and so that's why the Ethereum blobs costs increased to more than $127,000, right? And Celestia at the same time, so if you used, let's say, the data availability layer, was pretty flat. All right, so that's obviously because most of the layer 2s are using Ethereum blobs and not alternative data availability solutions. But as you see, and that is also another thing that you might want to consider as a builder, what you can read from the data, let's say, that Celestia is pretty flat, so it's more predictable actually, right? So because you don't want as a builder that all of a sudden you actually make a loss because of high blob fees. And if the tech is like not as efficient as you wanted it to be, then you actually make a loss, right? We can look at this from a different angle as well, and that's again the same day. And looking at Base compared to Linear here, for example. So you saw these huge spikes, and also the red one, this spike, is again the cost that Base had in this moment. So the cost was just too high because blobs were very, very expensive in this moment, right? And they were not cleared quickly enough. And so basically in the moment when the user actually transacted on Base, they still charged the cheap fees from their users. But once it was actually then settled on L1, the L1 fees were already much higher, so that's why actually the loss occurred for Base. But compared to that, Linear actually had nothing, right? You see a very flat line here, because Linear apparently has an ability to predict when the L1 cost will be high, so they're actually waiting a bit to actually settle on L1. And that allows them to actually still stay profitable and not operate at a loss in such moments where we have like a very high demand on the chains, for example. And so basically, again, same day, another metric, looking at it from a user's paid perspective. So imagine you're a user now on these layer 2s, and we actually, like, you think like, yeah, it always costs like 1 cent, right? But all of a sudden, then, I mean, 86 cents is still good if you, I don't know, getting a good airdrop, for example, but still you don't expect like to pay maybe around $1 for a transaction, right? But that happened on Arbitrum 1, and that's why they actually had a lot of revenue in this moment in time. So basically, a little summary to that. So we need to kind of look at different metrics and allow also very, very different people to look at these metrics, especially also builders, and that's why we are building the platform the way we do, to say, look, most of the people are actually not data experts, right? And they might not actually have the money to hire data scientists, etc. But we want to make this accessible. So basically the different metrics like throughput, revenue, on-chain, profit, that gives also a builder, let's say, an insight into the different scaling solutions that we have. And of course, the tech, you have to know a bit about the tech. For example, when you then talk about Tycho, we might have like a minute to actually look at that. Then you also need to keep in mind, okay, what's actually happening with my tech that I'm building on. And that's why we have different rollups and chains for different purposes, obviously. That was it so far. Thank you very much. And if there's questions, I'm happy to answer them right now, or I kind of show a couple of other metrics. I think we have a couple of minutes maybe to have a look at the actual, getting thumbs up. But we have one question over here.
Hi, thank you for the presentation. I saw you mentioned Celestia versus Ethereum blobs, are there any insights on any other DA layers like Veil, EigenDA, or any new ones?
Yeah, that's a good question. Right now, I mean, we are only tracking Celestia and Ethereum call data or blobs right now, but there's also there's one reason for it as well, and I think I have it open somewhere here without kind of I mean, I don't want to say one is better than the other, but in production right now, actually, most of them are using Celestia as a data availability provider, right? So that's why I think you can also see that here on the fees. But still, the bigger ones are actually using blobs, like Ethereum blobs and Ethereum call data. And there's a couple that actually, then here we have one Mantle with EigenDA. For example, Mantle is pretty big. But I think you see the same pattern there, that actually the cost for the data availability is more predictable right now, because everyone thought look, blobs are so cheap on Ethereum, so I don't have to worry about it. And especially you saw it in that moment, what I was talking about the whole time, that, for example, Blast as well, they could have had a cheaper transaction to L1 if they used call data, right? But since they were all by default using blobs, they actually overpaid, sometimes by, there's a good thread actually, by 10 times or 50 times even in that moment. So, and with Celestia, it's just you have a kind of a predictability that's actually pretty steady, the cost. Yeah.
Got it. And the second question, you showed the charts for profit for L2s.
Yeah.
And there's actually interesting, the same thing for DAs, because they have some costs, maybe some other types of costs, and some revenue.
Yeah.
Do you have any analysis on that?
We don't have how profitable Celestia right now is, for example. We don't have that. I mean, we just could, you could see right here, I think. Let's see. No, actually, it's a blob producer, so that's the amount of, so that's actually the ones that are using. Let's see if we can do that. So you see that actually Celestia is actually pretty well used, let's say. And compared to that, we have the Ethereum blobs. So let's say 1/3 Celestia right now, 2/3 Ethereum blobs. But what you also see, and I think that's just going to increase the more, is actually being used by these different layer 2s. You see that actually Celestia is very, very cheap, right? Overall, there's not that much that, let's say, a layer 2 right now has to pay for Celestia. That's just yesterday, and they made 230 in revenue from the layer 2s that are right now using Celestia, right? So there's a lot of capacity right now in Celestia, but so that there's a lot more room to grow, actually, yeah. Question. Any other questions? Yep, one over there.
I'm kind of curious. Thanks a lot for the presentation. I'm kind of curious, what is your stack for powering all the visualization and?
Right now we use hypercharts here as well a lot. Do you mean for creating the platform, or?
I mean, how are you getting all the data?
Okay, so we get the data from RPCs. We kind of aggregate the data, and then we have the metrics. And you, by the way, if you want to use the data, also you can just go to our API here, and get it free of charge, basically. All the data that you see on the front end, you get it through JSONs then as well. So it's pretty simple actually to use the data for your own analysis, for example.
Cool, thank you.
Welcome. All right. Yeah. Cool. Then thank you very much.